Imagine for a moment what it is like to be the loneliest object in the universe. You are floating in a darkness so absolute that the human mind cannot comprehend it. You are 14 billion miles away from home. The sun, the star that gave you life, is now just another bright dot in a sea of stars, barely distinguishable from the rest. You are drifting through the radioactive fog of interstellar space, a place where no human object has ever been before, and you are dying. For 47 years, you have been talking to the people who built you. Every single day, for nearly half a century, you have sent a faint whisper back to Earth, a heartbeat, a signal that says, I am here, I am still watching. But then, on a random Tuesday in November 2023, the voice stopped. The signal was still there. The carrier wave was humming across the void, but the words were gone. Instead of science data, instead of engineering logs, the spacecraft began to scream. It started spitting out a chaotic, nonsensical stream of binary code, ones and zeros that meant nothing. Gibberish. On Earth, the screens at NASA's Jet Propulsion Laboratory froze. The engineers stared at the data, and their stomachs dropped. This wasn't just a glitch. This was a stroke. The computer brain of the most important explorer in human history had shattered. Voyager 1 was gone. For 5 agonizing months, the world's smartest engineers fought a battle across the solar system to save a machine built with 1970s technology. They had to perform brain surgery on a patient that was 14 billion miles away, using a connection slower than a dial-up modem, knowing that one wrong move would silence the spacecraft forever. Today, we are going to tell the story of the greatest hack in history. We are going to talk about how we almost lost our ambassador to the stars, and why, inevitably, the day is coming when the silence will be permanent. To understand the weight of this silence, you have to understand the machine itself. Voyager 1 is not just a robot, it is a time capsule. It is a ghost from a different era. When Voyager launched in 1977, the world was a very different place. Jimmy Carter was president. Star Wars had just hit theaters. The internet did not exist. Your cell phone today has roughly 200,000 times more processing power than Voyager 1. The computer that runs this interstellar ship has less memory than the key fob you use to unlock your car. It was built for a mission that was only supposed to last 5 years. Its job was simple: fly past Jupiter and Saturn, take some pictures, and then die. It was a suicide mission. Nobody expected it to survive the radiation belts of Jupiter. Nobody expected it to last long enough to leave the solar system. But Voyager refused to die. It flew past Jupiter and showed us storms twice the size of Earth. It flew past Saturn and showed us the intricate beauty of its rings. And then, instead of shutting down, it just kept going. It kept drifting, powered by a dying heartbeat of plutonium, further and further into the dark. In 2012, it did the impossible. It crossed the Heliopause. It punched through the magnetic bubble that surrounds our sun and entered interstellar space. It became the first human object to leave our solar system. It was no longer exploring our neighborhood. It was exploring the galaxy. And for 11 years, it was our only eye in the dark. It told us what the universe smelled like outside our bubble. It measured the density of the plasma between the stars. It was sending back data that rewrote textbooks. Until November 14th, 2023. It started with a computer called the FDS, the Flight Data System. This is the part of Voyager that acts like the conductor of an orchestra. It takes data from the science instruments, packs it up into a neat package of binary code, and hands it to the radio transmitter to beam back to Earth. Suddenly, the FDS began to loop. It got stuck. Instead of packaging data, it started repeating the same pattern of ones and zeros over and over again. It was as if Voyager had forgotten how to speak. At NASA, the team realized the horror of the situation immediately. This wasn't a problem with the radio. The radio was screaming loud and clear. The problem was with the mind, the memory. Something inside the computer's memory bank had corrupted. Now, if your laptop crashes here on Earth, you walk over to it and press the restart button. If that doesn't work, you take it to a repair shop. But how do you fix a computer that is 15 billion miles away? The distance is the real enemy here. Light, the fastest thing in the universe, Takes 22 and a half hours to travel from Earth to Voyager. Think about that. If you send a command to Voyager saying, "Are you okay?" you have to wait 22 hours for that command to arrive. Then Voyager has to process it. Then it sends a reply. That reply takes another 22 hours to travel back to Earth. That is a 45-hour round trip for a single line of code. It's nearly 2 days of silence between every single keystroke. Imagine trying to defuse a bomb, but every time you cut a wire, you have to wait 2 days to see if it explodes. For weeks, the team tried the basics. They sent commands to restart the system. Nothing. They sent commands to reset the software. Nothing. The gibberish continued. The silence grew louder. People started to write eulogies. Articles appeared online. Is this the end of Voyager? Goodbye to the greatest explorer. It felt inevitable. The spacecraft is 46 years old. Its plutonium generator is decaying. It is freezing cold. It is being bombarded by cosmic rays. It was a miracle it lasted this long. Maybe this was it. Maybe the radiation finally fried a chip and Voyager was brain dead. But the engineers at JPL refused to give up. They dug into the archives. They pulled out paper manuals from 1974, documents that hadn't been touched in decades. They had to relearn the assembly language of a computer that was built before many of them were even born. They were looking for a needle in a haystack, blindfolded, while the haystack was moving away from them at 38,000 miles per hour. In March 2024, they tried a poke. They sent a command to the FDS memory, a digital nudge. They told the computer to try and read a specific section of its own memory and send it back, even if it was broken. They hit send, and they waited. Tick, tock, 22 hours to get there, 22 hours to come back. 2 days later, the signal arrived. It looked like more gibberish. The public didn't think much of it. But one engineer at NASA looked closer. He saw a pattern. It wasn't the looped data from before. It was a memory dump. Voyager had heard them. It had vomited out its entire memory bank. Now they had the evidence. They combed through the code, line by line, looking for the corruption. And they found it. It was a single chip. One solitary chip of memory in the flight data system had failed. It represented about 3% of the computer's memory, but that 3% contained the code that told the computer how to run. It was likely a cosmic ray, a high-energy particle from an exploding star somewhere in the galaxy that had slammed into that specific chip and fried it instantly. That part of Voyager's brain was dead. It was never coming back. This should have been the end. You can't fly up there and solder a new chip onto the board. The hardware was broken. Game over. But software is flexible. The team came up with a plan that sounded impossible. If they couldn't fix the broken chip, they would bypass it. They would rewrite the code of the Voyager spacecraft to ignore the dead part of its brain. They would take the instructions that used to live on that fried chip, chop them up into little pieces, and hide them in the unused corners of the remaining memory. It was like moving furniture into a house that was already full. They had to find tiny pockets of empty space in the 1970s memory banks and squeeze the code in, ensuring that the spacecraft knew where to look for the new instructions. If they made a mistake, a single typo, a single misplaced address, they would overwrite critical system files. They could accidentally tell Voyager to turn its antenna away from Earth. If that happened, we would never hear from it again. It would be lost to the void forever. On April 18, 2024, they were ready. They typed out the code, the patch, the most dangerous software update in history. They hit send. The command raced away from Earth at the speed of light. It flew past the moon in 1 second, past Mars in 4 minutes, past Jupiter in 35 minutes. It took hours to pass Pluto, and then it entered the dark. It traveled for a full day, a tiny beam of radio waves hunting for a tiny metal box in the infinite black. And then, the wait began. The control room at JPL was quiet. 22 hours out, 22 hours back. April 20th. The return signal was due. The engineers stared at their monitors. They were looking for the heartbeat. They were looking for the familiar stream of engineering data that said, "I am healthy. At first nothing, just the carrier wave, the static of the universe. And then the screen flickered. Data. Real, readable, coherent data. The loop was gone, the gibberish was gone. Voyager 1 was speaking English again. Cheers erupted in the control room. Men and women who had spent months living in dread burst into tears. Across 14 billion miles of emptiness, the little robot had heard them. It had accepted the transplant. It had reorganized its own brain and woken up from the coma. It was alive. It was a miracle of engineering. It proved that even at the very edge of existence, human ingenuity can reach out and touch the impossible. We had snatched Voyager back from the grave, but the relief was bittersweet, because everyone in that room knew the truth. We bought time, but we didn't buy forever. Voyager 1 is powered by a radioisotope thermoelectric generator, RTG. It runs on a ball of plutonium-238 that generates heat as it decays. That heat is turned into electricity, but physics is relentless. The plutonium is decaying, the half-life is ticking down. Every year, Voyager generates 4 watts less power. The engineers have already turned off the heaters. They have turned off the cameras. They have shut down the cosmic ray subsystem. They are stripping the spacecraft down to its bare bones, turning off every non-essential organ just to keep the heart beating. Sometime around 2025 or 2030, the power will drop too low. The voltage will collapse. The radio transmitter will flicker and die. There will be no gibberish that time. No glitch, just silence. The antenna will still be pointed at Earth. The computer might even still be trying to think, but it will have no voice. The signal will vanish from our screens, and Voyager 1 will become truly alone. But dead is the wrong word. Even when the battery dies, Voyager will not stop. In the vacuum of space, there is no friction. There is no air to slow it down. It is moving at 38,000 miles per hour, and it will keep moving at that speed essentially forever. In 40,000 years, it will pass within 1.6 light years of the star Gliese 445. In a few million years, it will likely drift through the spiral arm of the Milky Way. Long after the pyramids have crumbled to dust, long after our cities are gone, long after the human race has either left this planet or gone extinct, Voyager 1 will still be out there. It will be a silent, dark metal tombstone drifting through the stars. And attached to its side is a golden record, a 12-inch gold-plated copper disc containing sounds and images from Earth. It has the sound of wind, of thunder, of birds. It has music by Mozart and Chuck Berry. It has greetings in 55 languages. It has the brainwaves of a woman in love. When the power fails, Voyager changes from a scientific instrument into a message in a bottle. It becomes the final testament that we existed, that we were here, that we were curious, and that we were brave enough to throw a piece of ourselves into the dark just to see what was out there. The glitch of 2023 was a warning. It reminded us how fragile our connection to the cosmos really is. It reminded us that everything is temporary. So the next time you look up at the night sky, spare a thought for that little metal box 14 billion miles away. It is cold, it is tired, it is running on empty, but it is still flying, it is still fighting to stay awake, and it is the only thing out there that knows our name. For now, the silence has been broken, but the long night is coming, and Voyager will face it the same way it has faced everything else for the last 47 years. Alone and unafraid.